Hello, hello, my dear friends. Anyone is in live? Hello, hello. Anyone is in live? Good evening, Amit. Good evening. Good evening, Joshita. Good evening, Akshara. Still anyone is in live? Still anyone is in live? Hello. Now, right. Now we'll start the lecture. Now the many of the students, they will dislike or they will hate the chapter that we call it as a mole concept. Actually, the mole concept, it is a very easy when you understand the terminology of the question and when you understand the concept or the given data. We have to solve the question according to the given data. I hope it is clear for you. Before going to start the lecture, I want to ask whether the audio and the video is clear. Whether the audio and the video is clear. If the audio and the video, if it is clear, just you say me yes, so that I can start the lecture. The one who are in the live, just say me whether the audio and video is clear. Is the audio and the video is clear? Clear. Right. Now we'll start the lecture, that is a mole concept. Now, mole concept, it is a yes. Okay, fine. Good. Now, before going to start the mole concept, clear? Now, mole concept are the basic concepts of the chemistry. No, I will cover total chapter, not important, from the starting to ending. Mole concept, stoichiometry, everything. Then after that, redox reaction, everything I will cover. Right. In the mole concept, the first thing here, we have to know about the atomic mass. Clear? Now, before going to start or before going to know about the atomic mass, good evening Rishita, good evening. Before going to know about the atomic mass, just I want to give you one example. Like, what is our one example? Let's suppose I was taking the one box. This is a one box. Let's take its weight is 1 kg. Now, this is the one standard reference I was taken. Okay. Now, hi my dear, the one I cannot I cannot say your name. Good evening Jasmine, good evening. Just right? Now let's take, this is a good evening Yogesh, good evening. Now here just one substance I was taken. Now it is having the 1 kg. Now its weight, it is a kg. What is the meaning of the kg? That is a unit that we was given for that one. Okay, one substance weight is how much? 1 kg, right? Now with the help of this 1 kg reference, I want to calculate some let's suppose, let's take one substance, or better we'll take the one cylinder, will take. Okay, just we'll take the one cylinder, right? Now how much is the weight of this cylinder I want to calculate. Now to calculate this weight of this cylinder, I just need the reference, right? Some reference number or reference weight I require. So if I take this weighing machine, in this weighing machine, let's suppose here I just kept the cylinder now, and here I kept the our reference weight 1 kg. Then here let's suppose when I kept this cylinder here, now the same cylinder and the both has become balanced when I kept the same this 1 kg substance, let's suppose 200, let's suppose. Okay, means when I kept this substance 200 at the right hand side, clear? Sure. I will explain the leftover topic, bent rule, everything in the next class. Tomorrow or day after Sunday, I will take the one class. There I am going to explain. My dear friend, I am from the Hyderabad. Clear? Now you see this weight, if I kept it here, when I kept this our reference weight 200, then the both has become equal. Then can I say this weight of this cylinder is 200 into weight of 200 into weight of substance, 200 into the weight of the substance, can I say? Clear? Means when I kept this 1 kg substance here, 200 substance when I kept, then this what cylinder weight has become, I mean both the weighings has become equal. Means with the standard reference only we have calculated the weight of this one. So if I want to calculate any other substance or human or any weight, I was to take the reference, right? In the same way, to calculate the weight of the atomic mass, to calculate the atom's mass also, we need some reference. Now what is that reference we are having? For that, to calculate the atomic mass, we are having the reference. That reference we are having weight of single atom of an element, by 1/12 part of weight of single atom of carbon 12 isotope. This is a one standard reference we are having to calculate the atomic mass. Clear? This atomic mass we call it as a relative atomic mass. I hope it is clear. With this reference only we are calculating the what atomic masses of the given substance. We know, right? This atom contain what? Nucleus. In this nucleus we are having the protons and the neutrons, and the electrons will be revolving around it. So if you want to calculate the atom, atom mass. So you have to take the mass of the proton, mass of the neutron and mass of the electron. Mass of the proton, mass of the neutron and as well as a mass of the electron, right? Now we know mass of the proton. How much is the mass of the proton? Can anyone say me? How much is the mass of the proton? How much is the mass of the proton? Can anyone? Can anyone say me how much is the mass of the proton? Yes. 1.673 into 1.673 into, now the mass of the proton we are having 1.673 into 10 to the power minus 24 gram, right? Now the mass of the neutron is having the 1.678 into 10 to the power minus 24 gram. Now mass of the electron is equal to 9.1 into 10 to the power minus 28 gram. Clear? Now this is the weights of the mass of the proton, mass of the neutron and mass of the electron we are having. See, in comparison with the mass of the proton weight, mass of the electron weight is very less. This is a less, right? In comparison with the mass of the proton, mass of the electron weight is less because we are having the 10 to the power minus 24 and we are having the 10 to the power minus 28. 10 to the power minus 24 is greater than the 10 to the power minus 28, right? So in comparison with the mass of the proton, mass of the electron is negligible. So if the mass of the electron is negligible, then atomic mass we can calculate only on the basis of mass of the proton plus mass of the neutron. Now here also you can see, here mass of the proton and the mass of the neutron, it is having 1.673 and it is having 1.678. Very small, means almost very equal, right? So can I say it as a, because almost equal weights we are having. So what I was taking, mass of the proton is almost equal to the mass of the neutron. Then this mass of the neutron, can I write it as a mass of the proton plus mass of the proton? Clear? Mass of the neutron also, can I take it as a mass of the proton? Means atomic mass can be calculated on the basis of mass of the proton plus mass of the neutron. Now here the relative atomic mass. Now for that one they have given a one standard relative atomic mass. Now to calculate the atomic masses of the any atom, they have taken a one standard reference. Now they have taken, that is a carbon-12 isotope. Carbon-12 isotope is taken as reference atomic mass. Carbon-12 isotope is taken as a reference atomic mass of carbon C12 iso of atomic mass. Clear? Now you can see this carbon C12 isotope is taken as a reference for the atomic mass. Now for this one they have given a one unit called as a 1 AMU. 1 AMU is equal to 1 by 12 into mass of 1 carbon C12 atom or 1 carbon C12 isotope atom, right? If you want to calculate this mass of one carbon atom, just now we have seen what we have seen. To calculate the mass of the atom, mass of the electron is neglected, if the mass of the electron is neglected, then we have mass of the proton and the mass of the neutron only. Then here also, to calculate the mass of one carbon C12 atom, in the one carbon C12 atom, what we are having? In one carbon C12 atom, we are having 6 protons plus 6 neutrons and 6 electrons revolving around it. Now the 6 electrons we can neglect. Then the leftover atomic mass of the one carbon C12 atom is on the basis of only 6 protons plus 6 neutrons. 6 protons plus 6 neutrons. Good evening, Yashwant, good evening. 6 protons plus 6 neutrons, right? Then to calculate that 6 into mass of the proton plus mass of the neutron. Now, my dear friends, today I will not take, tomorrow I can take. Tomorrow I will start the biomolecules for you. Today I will not take. Now you can see mass of the proton, clear? Now mass of the proton and the mass of the neutron is almost equal. So can I say the 6 neutrons is also a mass of the proton? Then it will become the 12 into mass of the proton. Sir, 12 into mass of the proton, 6 mass of the proton plus 6 mass of the proton. This neutron also I was considered as a mass of the proton. Both are equal, right? So 12 into mass of the proton. Then 1 AMU. Then 1 AMU is equal to 1 by 12 into, then mass of the one carbon C12 atom, how much I got? 12 into mass of the proton, right? 12 into mass of the proton. Now just now only it has started 12 into mass of the proton. Here the 12 it gets cancelled. Then 1 AMU is equal to 1 mass of the proton. 1 mass of the proton we know, right? 1 AMU is equal to 1.673 into 10 to the power minus 24 in gram. Clear? 1 AMU if you want to calculate in the gram. Now this is a 1 AMU is equal to 1.67 into 10 to the power minus 24 grams. I hope it is clear for you. I hope it is clear for you. I hope it is clear for you. 1 AMU is equal to 1.673 into 10 to the power minus 24 gram. Is it clear or still you are having any confusion? Now 1 AMU will be equal to mass of the proton in the grams. Mass of the proton in grams. Right? Now next one, relative atomic mass. Now just now we have seen the relative atomic mass formula. That relative atomic mass formula, what we are having? Just now we have seen the relative atomic mass formula. Weight of the single atom of an element by 1 by 12th part of weight of single atom of carbon C12 isotope. Carbon C12 isotope, right? Now, next one, here relative atomic mass. This whatever the relative atomic mass we are having, relative atomic mass has no units. Sir, how the relative atomic mass is having the no units? See, if I compare mass RAM, relative atomic mass of oxygen, clear? Hi Priyansh, hi. If I want to calculate the relative atomic mass of oxygen, then what is the atomic mass of the oxygen? Now atomic mass of the oxygen is 16 AMU. 16 AMU. Now thank you Priyansh. Now RAM of the, if I ask AL, that is a 27 AMU. If I ask the nitrogen, now that it is having the 14 AMU. It is having the 14 AMU. Clear? Done? Thank you my dear friend, thank you my dear friends, thank you. Now this type of the comments, it will be make me to do more, to give the more content for you and make you do more classes. Okay, right. Now if I want to calculate or if I want to relate RAM of oxygen, right? Now atomic mass of the which one? Now 1 by 12th, this one just now we have seen right here. What is the formula we are having? Relative atomic mass formula, what we are having? Relative atomic mass formula we are having weight of single atom of an element by 1 by 12th part of weight of single atom of carbon C12. Now this 1 by 12th part of weight of single atom of carbon C12 isotope, we got how much? Can anyone say me? That's what I am saying. What is relative atomic mass means weight of single atom of an element by 1 by 12th part of weight of single atom of the carbon C12 isotope. I was asking 1 by 12th part of weight of single atom of carbon C12 isotope is equal to 1 AMU, right? That it will be equal to 1 AMU. See, 1 AMU is equal to 1 by 12th into mass of 1 carbon C12 isotope atom, right? This 1 AMU will be equal to the 1 AMU will be equal to the mass of the proton. Then can I write this as a relative atomic mass? Relative atomic mass will be equal to mass of 1 atom by 1 AMU. Mass of 1 atom by 1 AMU. Then mass of the oxygen we are having the 16 AMU by 1 AMU. This AMU will get cancelled. Relative atomic mass. We are relating the atomic mass of the oxygen with other. We are relating the which one? Oxygen with other. That is known as a relative atomic mass. Sure, I will explain. Now at the end I will explain. Why it is coming? What? That is just randomly it is coming. 16. So it is having no units. Randomly it is coming, my dear. Don't think about it. Now this is about the relative atomic mass. Clear? Then the next we are having. The next we are going to see. Sure, I will explain vapor density, everything I will explain. Right, 1 AMU is equal to how much? Mass of the proton we got. Next one, the next one we are having. The next we are going to see, that is how to calculate the molar mass. How to calculate the molecular mass or molar mass. What is the meaning of molar mass or molecular mass? Hi Rudra, hi. Clear? Now, what is the meaning of the molar mass? Sum of atomic masses of molecules. Sum of atomic masses of molecules present in it. See, if I want to calculate the NaOH molecular mass, now that it will be equal to atomic mass of sodium plus atomic mass of oxygen plus atomic mass of hydrogen. My dear friends, if you are serious, it is very much easy for you. If you are very much serious and if you follow the regular classes and if you are so serious, it is more than enough to crack your NEET. Okay? Oh, thank you, Rudra. Congrats, my dear. Congrats for your JEE. Now, right, next one. Now, atomic mass, we are having the 23. Now, oxygen atomic mass is 16 and hydrogen atomic mass is 1. Then if you add, how much you will get total? It is 17 and it is 23. 23 plus 17, it will give the 40. In this manner, we have to calculate the molar masses of the OH. Now if suppose if we have given the one substance, now can anyone calculate it and say me? Now what is the molar mass of HCl? What is the molar mass of HCl? Next, what is the molar mass of carbonic acid? Now what is the molar mass of H2SO4? Atomic spectra. Atomic spectra will comes under the atomic structure, right? Now this calculate it and say me. Calculate it and say me. HClO4, HClO4, CaCO3. Now say me. HCl is 36.5. Good. Carbonic acid. Carbonic acid. Carbonic acid. (36.5), 56. Now here 2 plus 12 plus 3 into 16. 3 into 16. Here 14. 14 plus 48. Here it is a 14. 14 plus 16 plus 16 plus 16. It will be 48. 48 plus 14. How much it will give? 62. Carbonic acid it is 62. Then H2SO4. H2SO4. H2SO4 how much? Let me complete. Let me complete, my dear friends. I can give you the very tricky and very high level standard of the questions for your mole concept, but I have to consider all the students, right? I am from Hyderabad, Telangana state. Now clear. Now the H2SO4 we are having the 98. Now the perchloric acid we are having the 1 plus 35.5 plus 4 into 16. If you do, you will get the answer. Now calcium carbonate it is a 40 plus 12 plus 3 into 16. It will give you the molar masses, right? In this manner we can find out the molar masses, right? The next concept we are having, that is average atomic mass. Average atomic mass we are having, right? Average atomic mass. What is the meaning of the average atomic mass? Clear. Many elements exist in multiple isotopes. Many elements exist in the multiple isotopes. Example, now carbon C12, carbon C13 and the carbon C14. Atomic number is same and the molar masses are different. Now if you take the hydrogen also, H1 and deuterium, clear, and the tritium. So many elements it will be exist in the nature in the multiple isotope. So to calculate its average atomic mass, now average atomic mass, to calculate the average atomic mass, average atomic masses of the isotopes, all the topics are from the 11 means basics of JEE. Yes, now one class is of the class 11th, one class is of the class 12th. Now you can check the timetable as well as you can check the playlist also. Now this formula we are having summation of percentage abundance into atomic mass by 100, atomic mass by 100. My dear friends, I am here to give you the free content if you are serious for your whatever may be the preparation you are preparing for. Clear? Done? Now, this is a formula, summation of percentage abundance into the atomic mass by the 100, atomic mass by 100, right? This is a formula. Just let's suppose, now if they ask calculate the, better I will give you one question. Now try to solve that question, right? Now try to solve the one question. Now I will give you one question. Right. Calculate the atomic mass of iron, its abundance of isotopes are 54 Fe, 55 Fe and 57 Fe. Its percentage abundances are now 20%, now 70% and 10% respectively. Now better you will take this as a 56 isotope, right? Respectively. Calculate AMM. Calculate it and say me. What is the answer? Calculate it and say me. Iron atomic number is atomic number already they have given. Already isotope atomic number they have given. What is the answer you got? What is the answer? Calculate it and say me. What is the answer you got? .5 mu. Now, what is the answer you got? Now you see, calculate. Now just you calculate the now see the formula we are having here, the 54, right? Percentage abundance we are having average atomic mass is equal to 54 into 20 plus 56 into 70 plus 57 into 10 by percentage. If you calculate, if you add, it will become the 100 only. It will become 100. Done. Now if AAM is equal to, if you do, it will be what? It will give you the answer for you, right? The next question I will give you, if you multiply and if you divide it by the which one, 100, it will give you the answer for you, right? Now next one, an element E has two isotopes. An element E has two isotopes, that is E24 and E26. If the average atomic mass is 24.6 U, means AMU, the average atomic mass is 24.6 AMU, what is the percentage abundance of E26? What is the percentage abundance of E26? My dear friends, stop the unnecessary discussion in the chat box. My dear friends, try to stop the unnecessary discussion in the chat box. My dear Yogesh, try stop the unnecessary discussion. Now what is the answer? What is the answer you got? What is the answer you got? Now, my dear friends, I was given a one question. Try to solve this question and say me the answer. Here some E element they have given, atomic masses they have given. Okay, he is asking the percentage abundance, and average atomic mass also they have given in the question, 22.4, 24.6 they have given. Now see me, 30%. 30% I think. Yogesh is saying 30% I think. Rest any other? Rest any other? %30%. Right. Now how to solve this question? Now you see, here average atomic mass formula, we know that average atomic mass they have given 24.6. Now the percentage abundance of the, which one is asking? E26, right? E26 you take it as a x into 26, plus for this one E24 the percentage abundance you take it as a 100 minus x into 24 by 100. Clear? Then if you take it this 100 to the left hand side, then it will become 24.6 into 100 equal to 26 into x plus 2400 minus 24x. Now if you solve this entire, you will get the x value, right? I hope it is clear for you that the x value you will get it as 30%. That 30% is the abundance of the E26 and leftover will be the E24. 70% will be the E24. Clear? I hope it is clear for you. Now next one. Now the next we are moving to the mole concept. Right. Now what is the meaning of the mole concept? Now why this mole concept it has came? Here the mole concept means, in this mole concept we will refer to the 1 mole. One mole contain Avogadro number 6.023 into 10 to the power 23. Actually, how this Avogadro number it has came? Clear? How this 6.023 into 10 to the power 23 it has came for the 1 mole. Now the 1 mole is referred as 1 mole. 1 mole is a amount of substance. 1 mole is a amount of substance that contain many entities as number of atoms in exactly 12 gram of carbon C12 isotope. Now we know 12 AMU, 12 gram contain 1.66 into 10 to the power minus 24 gram. That is the weight of one carbon C12 atom. Entities means many particles, either it may be the atom, either it may be the molecule, either it may be the ions, like that. Clear? Right? Done. See, just what is saying, 1 mole contain 6.023 into 10 to the power 23 either entities. What is the meaning of the entities? Means these entities may be the atoms, these entities may be the molecules, these entities may be the ions. Clear? See, 1 mole is the amount of substance that contain many entities as number of atoms in exactly 12 gram of 1 carbon C12 isotope. Means how much entities that are present in the 12 gram of 1 carbon C12. Now that it is referred as a 1 mole. That entities may be the atoms, molecules and ions. Clear? My dear Yogesh, I hope you have understand. I think so. Don't do any unnecessary text or anything here. I hope you can understand. Right? Now here the 12 gram of 1 carbon C12 isotope. We know, right? See, 12 gram 1 AMU will be referred to the 1 mass of the proton. So 12 into 1.66 into 10 to the power minus 24 gram, that is referred to the 1 carbon C12 atom. Then 12 gram of 1 carbon C12 atom contain 12 AMU, right? 1 AMU will be referred to the 1.66 into 10 to the power minus 24 grams. So 12 gram of 1 carbon C12 isotope contain how many atoms? How many atoms or how many entities? That entities, in that one entity I was taken, that is an atom. So one carbon C12 atom contain 12 AMU. The 12 AMU means one mass of the proton. So 12 into 1.66 into 10 to the power minus 24 gram. Then 12 gram of one carbon C12 isotope contain how many atoms I want? So just you do the crisscross. Let's you take it as this as a X, and you just, if you do the crisscross, then 12 gram of one carbon C12 isotope equal to 12 gram of one carbon C12 by 12 into 1.66 into 10 to the power minus 24 gram. Here the 12 get cancelled, clear, and gram get cancelled. Then 12 gram of one carbon C12 contain 12 gram of one carbon C12 contain 6.023 into 10 to the power 23 of carbon C12 atoms. I hope it is clear for you. How, sir? How this 6.023 into 10 to the power 23 it has got? This is 1 by 1.66 into 10 to the power minus 24. If you do, you will get it as a 6.023 into 10 to the power 23 of one carbon C12 atom. Means what he is saying, this 12 gram of one carbon C12 contain how many entities, how many carbon atoms? Avogadro number. This number refer for the Avogadro number. 6.023 into 10 to the power 23 of carbon 12 atoms. Clear? I hope it is clear for you. Yes. One carbon 12 atom contain 1 AMU. That is 12 into mass of the proton. Then what is saying? 1 mole is the amount of the substance that contain many entities as number of atoms in exactly. How many atoms that are present in the 12 gram of one carbon C12 atom, that it will be referred as a 1 mole. So now in the 12 gram of one carbon C12 isotope contain how many atoms? If we calculate, we got it as a 6.023 into 10 to the power 23 of carbon C12 atoms. We got, right? Then next one, this one they have given it as a Avogadro number. Now what is the meaning of Avogadro number? Exactly this Avogadro numbers of the atoms we are having, right? Clear? Avogadro's number. Now 1 mole of hydrogen atom, 1 mole of hydrogen atom equal to Avogadro number. This Avogadro number will be represented as a one capital N, and it is represented by the one capital N and the capital A, right? Now my dear friend, for the 94 percentile, once you try, you may have a chance to get clear. Now 1 mole of hydrogen atoms will be equal to the Avogadro number of the atoms, right? Next, 1 molecule or 1 mole of H2O molecules, 1 mole of H2O molecules will be equal to the Avogadro number means 6.023 into 10 to the power 23 molecules. Clear? Next, this is one very important point that you have to remember. 1 gram atom is equal to 1 mole of atoms. 1 gram atom is equal to 1 mole of atoms. Clear? 1 gram atom is equal to 1 mole of atom. That 1 mole of atoms contain Avogadro number of atoms. Just now we have seen. This is a one very key point you have to remember. 1 gram atom is equal to 1 mole of atoms. That 1 mole of atoms is equal to Avogadro number of atoms, right? Next, 1 gram molecule. 1 1 gram molecule is equal to 1 mole of molecules. 1 mole of molecules. This 1 mole of molecules contain Avogadro number of molecules. Avogadro number of molecules. Clear? Now, the same way, now how to identify? Clear? Thank you my dear Ancient. Now, you just subscribe and share to your friends also. And share to your friends and suggest the channel to your friends also. Right now, what is a gram per mole? Now, molecular weight is equal to gram per mole, right? Gram per mole. Moles is equal to weight by molecular weight. Now, weight is gram. Mole unit is a mole. If you take the molecular weight to the left hand side, then the weight by mole will be the which one? Molecular weight. Clear? Gram per mole is nothing but molecular weight. Right. Now, the next one we are having, what we are having? This number of moles. How to identify? See my dear friends, many of the students, they will get mistake and they will get confused here only. Where to use the which number of moles formula? Actually, the number of moles formula we are having, number of moles will be represented by the n, small n. In the question, if they have given, they are asking about the weights. In the question, if they are asking about the weights, for that one, the n is equal to given mass by molar mass. Given mass by molar mass. Right? If this is for the weight or mass. If they are asking for the weight or mass, this is a formula we have to use. Then n is equal to number of molecules or entities, either it may be the atoms or anything. Number of molecules or entities by Avogadro number. If you do in the questions, if they are asking about the molecules or atoms, then you can use this formula. Then n is equal to volume of gas at STP. Sir, what is the meaning of the STP? I will say volume of the gas at STP in liter by 22.4 liter or 22.4. My dear friend, this formula which we are going to deal, it is only for gas molecules. It is only for gas. It is only for the gas molecules and it is not applicable for the liquids. Right? It is not applicable for the which one? It is not applicable for the which one? It is not applicable for the liquid molecules. Right? Now, these are the formula we are having. Now, by using this formula, we have to solve the given questions. Now, we'll see how to solve the given questions. Direct. Molar mass is equal to mass of the atoms into Avogadro number. Clear? Now, if suppose here molar mass, my dear friends, first you be strengthened in the mole concept. If the mole concept, if you are strengthened in the mole concept, now automatically you will get the which one? You will get the physical automatically. Now, molar mass is equal to mass of the atom into Avogadro number. Mass of the atom into Avogadro number. Now you can see this is the mass of the atom into Avogadro number. Clear? 1 AMU is equal to 1 by Avogadro number. 1 AMU is equal to 1 by Avogadro number. Now we'll see here how the 1 AMU and how to calculate this type of the questions. Here now I will give you one question. Now try to solve these questions. Two gram atoms of HE, 2 gram atoms of HE contain 2 gram atoms of HE contain how much mass? Clear? Next, first question. Second question, 2 gram molecules of O2 contain how much mass? Same, my dear friends. What is the answer for the first question and what is the answer for the second question? What is the answer for the first question and what is the answer for the second question? What is the answer for the first question and what is the answer for the second question? 2 gram atoms of the HE contain how much mass? What is the answer for the first one and what is the answer for the second one? What is the answer for the first one and what is the answer for the second one? What is the answer for the first one and what is the answer for the second one? What is the answer you got? Eight grams. First one you got it as a 8 grams. First one you got it as a 8 grams. Second one you got it as a 64 gram. Right, my dear friends, you can see already just now I explained here 1 gram atom is nothing but 1 mole. 1 gram molecule is nothing but 1 mole of molecule. What I was given? 2 gram atoms I was given. This 2 gram atom, this gram atom is nothing but, yes, you are correct, Yogesh, you are correct. See, 1 gram atom is nothing but 1 mole, right? Then 2 gram atom is nothing but 2 mole. Then 2 gram atom of helium is asking. 2 gram of helium is nothing but 2 moles. 2 moles of helium contain how much weight? Now write the number of moles formula and is asking the mass. For the mass, the formula we have to use N is equal to given mass by molar mass. So here the mass is asking, right? Number of moles how much you got? 2 is equal to mass is asking, and molar mass of the helium is 4. If you cross multiply, mass is equal to 8 grams. That's it. Next one, here this 2 gram molecule of O2. Now what is the meaning of the 2 gram molecule of the O2? Here 2 gram molecule of the O2 contain how much mass is asking. Here one, that is nothing but 2 gram molecule is nothing but 2 moles. Now again is asking the mass, right? Now 2 into mass by mass of the oxygen O2 is 32. If you cross multiply, mass is equal to 64 gram. That's it, simple. 64 gram. Next one. Okay. My dear friends, you have to give me the answer. Now, right. He is asking next one. The one very important formula we are having. That is, what is the formula that we are having? If they ask number of atoms, if they ask formula, number of atoms is equal to number of moles into number of moles. Number of atoms formula, if they ask the number of atoms formula, easily you can remember that. What is the formula you have to remember for the number of atoms? Number of atoms is equal to number of moles into Avogadro number into atomicity of that atom in that compound, right? That is number of atoms if they ask. Next, number of molecules. Better if you are getting what is the meaning of atomicity, and if you get the confusion, means what is the meaning of atomicity means. Now you see, let's suppose if I was given the H2O here, atomicity of hydrogen, if I ask, atomicity of the hydrogen is 2, because it is 2 it is present. Then atomicity of oxygen, if I ask, atomicity of oxygen is 1, right? Now next one, if I ask what is the atomicity of ozone, can anyone say me what is the atomicity of ozone? What is the atomicity of ozone? What is the atomicity of ozone? My dear Yogesh, once again I was warning you, don't disturb the others, okay, and don't interrupt the class. Now the atomicity of the ozone is 3, right? Atomicity of the ozone is 3. Now the number of atoms formula, just number of moles into Avogadro number into atomicity of that element in that compound. This is the one formula, just you remember. Next, number of molecules, if they ask, number of molecules is equal to Avogadro number into, number of moles into Avogadro numbers. Clear? Number of molecules, if they have given, n into Avogadro number. Now the based on these formulas, now we are having the some questions. Now what is that question? Just is asking how many oxygen atoms are in how many oxygen atoms are in 196 gram of H2SO4. Now say me my dear friends, how many oxygen atoms are in 196 gram of H2SO4? My dear friend, you are good boy only, okay, but don't interrupt. Just other than the concept or other than the questions, you just don't discuss anything. How many oxygen atoms are in 196 gram of H2SO4? Now you can take your time and send me the answer. You can take your time and you can say me. What is the answer you got? My dear friends, if you know the answer, you say me. If you don't know, you just give me the question mark. I am ready to explain. See, here he is asking about the atoms, right? Just use this formula. N into Avogadro number into atomicity of that element in that compound. Right? See, here now here the number of atoms of oxygen atoms is asking, right? Oxygen atoms is equal to 196 by 98 into 6.023 into 10 to the power 23 into 4 into 4. Okay, good Yogesh, good. Now this one will give you the 2 moles, right? 98 into 2, then it will give you the 8 into 6.023 into 10 to the power 23, right? Clear? Done. 8 into 6.6 into 10 to the power 23, 4.18, right? That will be the 24, right? 24. If you multiply, it will become 24 into 10 to the power minus 3. Just simple. Weight they have given. If you divide it by the H2SO4, it will get the number of moles. You will get the number of moles. Then after that, you will get the Avogadro number. After Avogadro number into 4. Now Yogesh, you also got the wrong answer. Clear, it is not the 4.817. It is a 8 into 6.023 into 10 to the power 23. Now this if you do, you will get the answer. Next one, he is asking the answer. He is asking the question for one question. What is the mass of 3.011 into 10 to the power 23 molecules of CO2? What is the mass of 3.01 into 10 to the power 23 molecules of CO2? What is the mass of 3.011 into 10 to the power 23 molecules? What is the answer? What is the answer you got? What is the answer you got? What is the mass of 3.011 into 10 to the power 23 molecules? Molecules, if they have given, use the number of moles formula according to the molecules. If they are asking the weight, use the formula according to the weight. If they are asking the volume, use the question or use the number of moles formula according to the volume. My dear friends, if you know the answer, you just say me. If you don't know, you just give me the question mark. I'm ready to explain. Mass is asking means that it should be in the grams only, right? Mass, if he is asking means that it should be in the grams only. I think so, Yogesh, you are using the calculator or something else. See, here molecule they have given, right? Now use this formula. What is the formula we have to use? See, this is a formula they have given, right? Now you see. Now for the molecules, the number of molecules or entities by the Avogadro number, this will give you the number of moles, right? Now use this formula. Use this formula. Now number of moles is equal to given molecules. How much? 3.011 into 10 to the power 23 molecules by Avogadro number. If you do into 10 to the power 23, if you do, you will get it as a how much? 1 by 2 mole. 1 by 2 mole, right? Now 1 by 2 mole if you get, he is asking the weight of in the 1 by 2 mole, how much weight of the what of the CO2 it will be there, right? Here 1 mole, number of moles, how much you got? Half mole, right? Now half mole into weight is asking, weight by what? CO2 it is having the 44. If you cross multiply, weight is equal to 44 by 2, if you do, you will get the 22 gram. 22 gram. Clear? I hope it is clear for you. I hope it is clear for you. Should I give the another question? Should I give the another model question? Should I give the another model of the question? Now I will give you the another model of the question so that it will be easy for you. Right. What volume does 6.022 into 6.022 into hi Asifa, hi into 10 to the power 22 molecules of O2 occupies at STP? What volume does 6.022 into 10 to the power 22 molecules of O2 occupies at STP? Now say me. Good evening Asifa, good evening Ashifa. Good evening Ashifa Rahman. Right, what is the answer for this one? Volume is asking. Then molecules they have given. So by the molecules formula you find the number of moles. Two formulas you have to use. Two formulas you have to use. Use it and use the formula and say me the question. Say me the answer. Okay. Okay. Good, Rahman, good. It is 2.24. See, my dear friends, that's it. Here, what is asking? Here, what is the volume of What is the volume does 6.022 into 10 to the power 22 molecules of O2 occupies at STP is asking. Right? STP condition, first molecules they have given. Find the number of moles. Number of moles is equal to 6.022 into 10 to the power 22 by Avogadro number, right? 6.023 into 10 to the power 23. Right? Here 6.022 or 6.023, almost it will be equal to 1. Right? Now if you bring this 10 to the power 23 to the numerator, it will become how much? It will become the 10 to the power minus 1. So the number of moles of the given molecule, we got it as a 10 to the power minus 1 mole. Then after that he is asking the volume, right? Now volume number of moles formula, N is equal to volume by 22.4 liter, right? Right, number of moles for the given molecule, the number of moles we got it as a 10 to the power 1. That it will become 10 to the power minus 1 into volume is asking into 22.4. If you do, you will get it as a 2.24 liter. You will get it as a 2.24 liter. Right? I hope it is clear for you. Or still you are having any confusion? I hope it is clear for you, or still you are having any confusion? My dear friends, I hope I got that you are getting the problem to identify the which formula to use for the which question. Just I will write the only 5 formulas I will write. Only based on that 5 formulas only the complete question will be there. Nothing more than that. Clear? Nothing more than that. Right? Yes, my dear Vishnu, this is a junior's class only, yours class only. Right? Only remember this formula. Number of moles is equal to weight by molecular weight. Just in the question, if they ask about weight, okay, right? Next one, n is equal to given molecules by Avogadro number, right? This is about molecules, right? Next one, n is equal to volume, given volume by 22.4 liter, right? This is yet STP condition, volume if they ask, right? Now based on these 3 formulas only, the questions they will keep on repeat. Clear? Right? Now we'll see how the questions they will ask you, how to interconvert those questions. Right? Here first one, number of moles. First the number of moles. First, if you want to find weight of the substance, or mass of the substance, if they are asking, just number of moles into molecular weight, if you divide, you will get the weight of the substance. Then weight of the substance, if they are asking number of moles, they will give you molecular weight, that substance, and weight of the substance. If they are asking, use this formula, number of moles into molecular weight of the substance you will get. Then weight of the substance given, this is weight of the substance given. If the weight of the substance given in the question means, use this formula, weight of the substance given divided by molecular weight, you will get the number of moles. Right? I hope it is clear for you. Then next one, number of moles and number of molecules, if they are asking about the molecules, right? if they are asking about the molecules. Number of moles, and if they are asking about the molecules, from the number of moles, if you want to find the number of molecules, how many number of molecules are given, that just you cross multiply, or if you multiply with the Na, you will get the number of molecules. Number of molecules asking, this is asking. Asking means number of moles into Avogadro number, if you do, you will get number of molecules. Then if suppose they have given in the question, given if they have given, just given if they have given number of molecules divided by Na, divided by Na. Now the next class tomorrow, my dear friend, daily the classes will be continue. Mole concept classes daily it will be continue. Friday, Saturday, Sunday, Monday, Tuesday, daily at the 7 p.m. the classes will be there. Right. Next, if suppose volume of the gas, if they are asking, volume of the gas, if they are asking, volume of the gas, if suppose if they are asking about the volume of the gas, number of moles and volume of the gas asking, volume of the gas asking, if the volume of the gas, if they are asking, multiply with 22.4 liter, multiply with 22.4 liter, right? Now volume of the gas given, volume of the gas given, then divided by the 22.4 liter, divided by the 22.4 liter. Only these are the interconversions. In these interconversions only we have to solve the question. Now with this interconversion, how to solve the question, now I will explain. Now listen. Now here the question is asking 44.4 liter of 44 liter of volume occupied by 44.4 liter of volume occupied by CO2 gas, 44 liter of the volume occupied by the CO2 gas. What is the mass of it? Clear? 44 liter of the volume occupied by the CO2 gas. He is asking what is the mass of it. Now use this formula. See, volume given is asking the, what is asking? He is asking the weight of the substance or mass of that substance. Volume, this one they have given, is asking this one. Then what you have to do? Volume given means you have to divide it by the 22.4. 22.4, see, 22.4, if you do divide, you will get the number of moles. After getting the number of moles, is asking, right? Asking means number of moles into molecular weight. If you multiply, you will get the weight of the substance, right? Weight of the substance you will get. Now how it is getting, now we'll see. Volume, how much they have given? 44.4 they have given, and if you divide it by the 22.4, you will get it as a how much? 2 moles. After getting the 2 moles, is asking the weight of the CO2. Then weight of the CO2, number of moles is equal to weight by molecular weight of the CO2 is 44, right? Number of moles I got it as a 2. I got it as a 2. Then 2 into 44 will be the weight of CO2. Weight of CO2, that it will become 88 gram. That's it. That only he has given. You can see volume given, just divide it by the 22.4. After getting the moles, multiply with molecular weight, you will get the weight of the substance, right? Should I give the another question? Should I give the another question? Now before question, you see this question, before question. In this question, what is the volume does 6.0222 molecules of O2 occupies? Volume is asking, right? Volume is asking molecules given. Now you see this formula. Here molecules given. Molecules given means divided by the Avogadro number. That only we did. See, that only we did. Given molecules divided by the Avogadro number. After we got the number of, which one? Number of moles. After getting the number of moles, see, after getting the number of moles, what we did? He is asking the volume, right? Asking means into 22.4 if you do, into 22.4 if you do, you will get the volume of the gas. That only we did. See, after getting the number of moles, I was multiplied the 22.4 liter. I was multiplied the 22.4 liter, I got the volume. Only if you remember this table, and according to the given question, you have to do the conversions. According to the given question, you have to do the conversions. I hope it is clear. Should I give the question or we'll move to the concept? Should I give the 2 more questions? 2-3 questions I will give you. I hope you will try it from your end. Now, right. Next question. How many total atoms are present? How many total atoms are present in 53 gram of sodium carbonate? 53 gram of sodium carbonate. Now say me, Na is equal to 23, carbon is equal to 12, oxygen is equal to 16. He is asking total atoms, total atoms. Now, atoms formula, you have to use this formula. Now, you have to use this formula. Total atoms. Atomicity of that atom means total atoms. If they are asking means how many atoms are there in this? How many atoms are there? That is the atomicity. What is the answer? Three, no. No. See, ma'am. Here, how many total atoms are present in the 53 grams of sodium carbonate? Now, what is the molar mass of the sodium carbonate? 23, 12 and 48, right? This will give you the 63. This will give you the 60. 60 plus how much? 46. How much it will give? 106. It will give you the 106, right? Then is given 53. 53 by 106 into Avogadro number into total number of atoms. How many? 2, 3 and 6. This is 6, right? This is 6. This one will give you how much? 1 by 2. This will give you the 3. That it will give you the 3 Na. Yes. Good. Good, Yamini. Good. Now the one question I will give you. Now try to solve it by your end. Two 2.5 liter of a gas, 2.5 liter of a gas at STP weighs 3.75 gram. Clear? 3.75 gram. Calculate the molar mass of the gas. Calculate the molar mass of the gas. Yes. Good, Amma Yamini. Good. Now, 2.5 liter of a gas at STP weighs 3.75 gram. Calculate the molar mass of the gas. What is the answer? Ma, if you don't know, give me the question mark. I'm ready to explain. Give me the question mark if you don't know or if you are trying. నీ ఇష్టం, యూ కెన్ చేయమ్మా. నీకు అప్రాక్స్ ఆన్సర్ వస్తే అప్రాక్స్ చేయి. నీకు అప్రాక్స్లో ఆన్సర్ వస్తే అప్రాక్సిమేషన్లో చెప్పు. 33 అంతే, 33.6 వస్తుంది. ఎస్ 33.6. సి 2.5 లీటర్ ఆఫ్ ద గ్యాస్ ఎట్ ఎస్టీపీ కదా. క్లియర్? నౌ వెయిట్ ఇచ్చినాడు, ఆ గ్యాస్ యొక్క వెయిట్ ఇచ్చినాడు. నెంబర్ ఆఫ్ మోల్స్ దే హ్యావ్ గివెన్, సారీ వెయిట్ ఆఫ్ ద గ్యాస్ దే హ్యావ్ గివెన్. ఈజ్ ఆస్కింగ్ ద మాలిక్యులర్ వెయిట్. వెయిట్ ఎంత ఇచ్చినాడు? 3.75 గ్రామ్ ఇచ్చినాడు. రైట్? ఈజ్ ఆస్కింగ్ ద మాలిక్యులర్ వెయిట్ ఆఫ్ ద గ్యాస్. మాలిక్యులర్ వెయిట్ ఆఫ్ ద గ్యాస్ ఈజ్ ఆస్కింగ్. తెలుగు. Okay, I will talk in English only. Okay. Now here, according to the given data, you need the number of moles, right? See, but he has given in the liter, right? Number of moles is equal to 2.5 by 22.4. If you do, you will get the number of moles. Okay, you will get the number of moles. The number of moles, how much you will get? According to the given liter of the gas, you will get 0.011116 something you will get. Okay, this is the number of moles. 0.1116 by, if you bring the 3.7 to the left hand side, by 3.7, sorry, not this one. Just if you bring the molecular weight to the left hand side, then what it will happen? Molecular weight of the gas is equal to 3.75 by 0.1116. If you do, you will get it as approx 33.6. you will get 33.6. you will get. No, 33.6 you will get. Good. Right. Now next one. Next 2 more questions I will give you and I will stop. This is one very important question, my dear friends. Try to do it by your end. Don't search in any Google or anywhere. If you do it in that manner, your thinking ability will be decreased. Right? Initially you may satisfy, but in the exams it will give you the tough. Right? Write a question. A gaseous mixture contains equal weights of oxygen and O3. Calculate ratio between number of molecules. Calculate the ratio between the number of molecules. Calculate the ratio between the number of molecules. What is the ratio? Calculate the ratio between the number of molecules. This is one type of the tricky question. A gaseous mixture contain equal weights. Equal weights he has given. Okay, you can try. I will wait. Don't worry. I will wait. A gaseous mixture contain equal weights. Calculate the ratio between number of molecules. Calculate the ratio between number of molecules. Good, Yamini, good. 3:2. Good. Good, Amma, good. 3:2. Ante. See. Yes, good. Good, Uzair. See, a gaseous mixture containing equal weights of O2 and the O3, right? Now the number of molecules formula. What is the number of molecules? Number of moles into Avogadro number. Clear? Right? Number of moles into the Avogadro number. What is the N formula? N is equal to weight by molecular weight. What is the molecular weight of the O2? That is 32. He is asking in the ratio. That weight, equal weights, right? Equal weights means something X you take. Something X weight you take. That is X. Ratio is asking, right? Ratio. Then X by 48. Right? That it will give approx. Here the XX get cancelled. That it will give you the what? 2 and 3. Approximately you will get the 3:2. 3:2. Okay, my dear friends, don't worry, they will give you the options. It is not any integer type questions or anything. Okay, don't fight about for that 1.5. 1.5 is also correct. Actually, that in the ratio, right? The ratio should be in the 3:2. Right. Next one, the last question I will give you, and I will start. Calculate the weight of Na3PO4, which contain same number of Na plus with 80 gram of same number of Na plus with 80 gram of NaOH. NaOH. Now he is asking the calculate the weight of Na3PO4 which contain same number of Na plus, which contain same number of Na plus with 80 gram of NaOH. With 80 gram of NaOH. This is one interesting question. Same number of Na plus, same number of Na plus with 80 gram of NaOH. If you know the answer, say me. If you don't know, try to give me the what question mark. I am ready to explain. Are you trying? Are you trying? My dear friends, are you there? Right. Okay. Should I explain? Yes, I will explain it. See what is saying. Yes. He is asking, just simple is asking. What is the simple thing is asking? What is the weight of trisodium phosphate? Trisodium phosphate weight is asking. So the trisodium phosphate weight is 262.4. యామిని ఒక్కసారి మ్యాథమెటికల్ క్యాలిక్యులేషన్ ఒకసారి క్రాస్ చెక్ చేసుకోమా. ఒక్కసారి క్యాలిక్యులేషన్ పార్ట్ క్రాస్ చెక్ చేసుకో. ఇక్కడ చూడు. నౌ లిజన్. వాట్ ఈజ్ ఆస్కింగ్? ట్రైసోడియం ఫాస్ఫేట్ contains same number of Na plus ion with the 80 gram of NaOH. Just you take, what is the formula you have to take? That number of atoms, right? Na plus ion is nothing but atom only. This Na plus ion is nothing but atom. So the same number of Na atom, the same thing that it is present in 80 gram of NaOH. Then the number of atoms formula, number of moles, right? Weight is equal to Na3PO4 by molecular weight of Na3PO4, you will get it as a 164 into how many number of Na we are having? How many number of Na we are having? Okay, my dear friends, I was using the English itself. Here the weight of Na3PO4 is asking number of moles, right? That is molecular weight is 164. Avogadro, how many Na atoms we are having? 3 into Na is equal to same number of Na atoms that are present in 80 gram of NaOH, right? 80 by 40, because molecular weight of NaOH 40 and number of Na is 1 into Na. Na get cancel, and if you cross multiply weight of Na3PO4 equal to, then if you cross multiply you will get the answer. How much you will get? Here approx you will get it as, here you will get the 2. Now 2 into 164 by 3. 2 into 164 by 3. Mole concept is for juniors only, right, Suraj? Now 2 into 164 by 3, how much you will get? Approx you will get 109.3 approx. I think so you have not taken the atomicity of the sodium. Atomicity of the sodium 262.4. I hope it is clear for you. Ardhamainda? Is it clear, everyone? I hope it is clear for you. Because in the NaOH we are having only one sodium. Only the one sodium we are having. Yes. Yes, 109 grams. Good, my dear friends. Good. I hope it is clear for everyone. Should I give the more questions? Or should I stop? Or we'll see you in the next class. Say last question I will give you based on this concept only. At least you try. Same concept I will give you, but different model. Same concept but different model. Calculate the mass of CO which contains same number of oxygen atoms in 88 gram of CO2. 88 gram of CO2. Now say me. 88 gram of CO2. $88 gram of CO2. My dear friends, I think so you are using something chat GPT or something else to get the answer. I hope don't do such type of the things. Actually, I was doing this classes for your good academic success or whatever the misconceptions you are having there to clarify. And what are the, my dear friend, once you cross check your mathematical calculation, I hope the mathematical calculation once you cross check, good 112 grams of the CO2. My dear friends, don't use any chat GPT or don't use any other Google or anything, because I was here to give you the good academic success for you. Still, if you are making me happy and for some other else if you want to make happy, at the end you will be the loser. Now same type of the question you can see here. Calculate the mass of CO which contains same number of oxygen atoms in 88 grams of the CO2. Same you take. Now weight of CO by what is the molar mass of the CO? 12 plus 16. 12 plus 16, that it will give you the 28. Clear? Now atomicity of the oxygen is 1 into Na equal to, now that it is contained in the 88 gram, right? 88 by 44 into atomicity of the oxygen is 2. Atomicity of the oxygen is 2. Clear? Into Na, right? Now Na get cancel, right? This one will give you the 2. Now this 2 into 2, it will give you the 4. Now weight of the CO is equal to 4 into 28. 4 into 28. The 4 into 28 approximately will give you the 112 grams. 112 grams. Is it clear? Weight of the CO will be the 112 grams. Right? Okay. Now, my dear friends, I hope it is clear for you. I hope it is clear for you. Just I will give you one question. Now I will see who will give you the answer in the comment box. Don't give the answer here. What is the answer for this question? Just you give me the answer of this one in the comment section. Now the one who gives the answer in the comment section, that answer will be pinned. I will see. Now what is the number of oxygen atom in 9.8 gram of 9.8 gram of H3PO4. H3PO4. Now I will see who will give the correct answer for this question in the comment section. I will see. Okay. I hope, my dear friends, if you are having any concerns, Joshita has asked me about the vapor density and the STP, right? Joshita, are you there? If you are there, I am ready to explain about the vapor density and at STP condition. Anyone are having any concerns? Anyone are having any concerns? Or if they want to ask anything? Anyone are having any concerns, or anyone are want to ask anything? They can ask. Or should I end? Should I end the live? My dear friend, should I? Am I explain చేయనా? Vapor density అంటే ఎక్కడి నుంచి ఎక్స్ప్లెయిన్ చేయను? Vapor density ఫార్ములా ఎలా వచ్చిందో ఎక్స్ప్లెయిన్ చేయనా? Now vapor density, my dear friends, how to learn the physical chemistry in the easy way means understanding of the concept and understanding of the terminology of the question. See, vapor density, actually the vapor density is related that density, vapor density, they have related density of a gas related to density of H2 at STP condition. At STP condition. Now, at STP condition ante standard temperature and pressure. Standard temperature and pressure. Actually, this STP condition, they have given the fixed temperature and the fixed. Okay. Now you see. Here the STP means, you know, right? STP means pressure is equal to 1 atm and 273 Kelvin. This is old condition. Now the pressure is equal to 1 bar and temperature is equal to 273 Kelvin. Now this is a new condition. Okay. Now vapor density to calculate at the standard temperature and the given temperature and the given pressure. Now the given temperature and the given pressure, if you want to calculate at the given temperature and the given pressure, that is known as a vapor density, right? That is known as a vapor density. Now here vapor density of the gas related to the density of the H2. Now how it is related and how the formula it has came, now we'll see. Vapor density is equal to density of gas by density of H2, right? What, my dear friends, is not, is there a equation is not at STP, then what we do? No, actually this is not at the STP condition. Sorry, this is not at the STP condition. She asked about the STP, so I was explaining, but vapor density we will not calculate at the STP condition. Now vapor density of a gas is related to the H2 at same temperature and pressure. Same temperature and pressure. Actually, what is the meaning of the STP? I was explained. Clear? STP means standard temperature and pressure. These are the notations. Actually, vapor density will be calculated at the same temperature and the pressure. Okay. Now, same temperature and the pressure. Vapor density of the gas is equal to density of the gas. But according to the ideal gas equation, we are having the PV is equal to nRT. Now, the number of moles formula, weight by molecular weight, right? P is equal to weight by molecular weight into R into T by V. This we know, right? Weight, if you interchange weight by volume into RT into molecular weight. Now, weight by volume is the density. Density is equal to weight by volume. We know mass by volume or weight by volume both are same. Clear? Now this one just we can write it as a P is equal to density into R into T by molecular weight. Right? Just density if you interchange. Density is equal to P into molecular weight by RT. Molecular weight by RT. The same thing. Here same temperature we are talking, right? We are talking about the same temperature and the same pressure, means same temperature and the same pressure, means here the pressure T will be cancelled out. R is the universal gas constant, that is constant only. What it is changing? Only the molecular weight of the gas is changing. So this is the formula. Now the same density of the gas and the density of the H2, you just put it in this formula. So vapor density is equal to pressure into molecular weight of gas by R into T by P into molecular weight of H2 by R into T, right? Now you see R into T, P and R into T, and the P will be get cancelled, right? The leftover vapor density will be equal to molecular weight of gas by molecular weight of H2 is 2. So this is a formula. Vapor density of the gas is equal to molecular weight of the gas by 2. I hope it is clear. I hope it is clear. I hope it is clear for you. I hope it is clear, and the remaining I will continue. I will continue the tomorrow's class. Yes, we have to use the ideal gas equation. PV is equal to nRT. The remaining I will continue in the tomorrow's class. Now from the tomorrow's class I will continue. Okay. Now I was ending the class here. Now see you tomorrow. My dear friends, still you are having any concerns? Anyone? Anyone are having any concerns? They can ask me. Anyone, if they are having any concerns, they can ask me. Anyone, if they are having any concerns, they can ask me. Okay, fine. Right. Now I was ending the class. Now see you tomorrow. See you tomorrow. Bye. Study corner. Now at the end of the class you have came. My dear friend, at the end of the class you have came. You are having any concerns? My dear friends, you are having any concern? Now tomorrow 7 p.m. the class will start. 7 p.m. class will start tomorrow. Tomorrow 7 p.m. the class will start. Tomorrow the class will start at 7 p.m. Right. Right. Okay, my dear friends, see you tomorrow. Bye.